Unit 1B, Introduction to Statistics, Data Types and Levels of Measurement. The variable is a characteristic which we are measuring or observing. So, for example, we could let x be a variable, and it could be equal to the age of a person. So when we're gathering data, we would say the first person is 5 years of age. We would say x is equal to 5. The next person is 7 years of age. We'll say x equals 7. Or x could be their favorite color. And for the first person, x could be green. The next person, x, which is also called a score, the score for the next person would be red, and so on. These are variables. Now, variables come in two types. They're numbers or words. So, categorical variable type is a word, and it also could be a number. Also, words are called qualitative variable type, and numbers, the number type, is also called quantitative. So we have two variable types. So if a person is asked for their arm length, arm length would be a number, so that would be quantitative variable type. If we ask a person for their religion, the name of their religion, that would be a word like Protestant. That would be qualitative, non-numerical, or categorical, because the answer would be a word. Now, numerical or quantitative variable types are divided into two categories, discrete and continuous. For example, if I ask a person, how many siblings do you have? Siblings are brothers and sisters. How many siblings do you have? Well, what kind of answers could I get? A person says, I have one sibling, or I have two, or I have none, or I have one, or I have three, or I have two, and so on. We would gather these numbers. This is numerical data. Now, if I put these numbers on a number line, and let's see, I'll just put a dot here to represent this first score of 1. Then we had a 2, then a 0, another 1, 3, 2, and so on. Notice that these numbers on the number line have gaps. There are spaces where there are no numbers. Now, could I have a number in between? Could I have, say, 2 1/4? Could I have 2 1/4 siblings? No. So we can only have these whole numbers. There are spaces in between where you cannot put a number. So these data are called discrete. Discrete means separate. They're separated by gaps. On the other hand, if you ask a person his height, a person could be 68 inches tall, or 69 inches tall, or 70 inches tall, and so on. If I put that on a number line, So we have 67, 68, 69, 70, 71. We're asking people how tall they are. So a person could be 67 inches tall, or 68, or 69, or 70, or 71. So that looks a lot like the previous picture we drew, except that could a person be 68.5 inches tall? Yes, that would be in here. Could a person be 68.25 inches tall? Yeah, that would be here. Could a person be 68.1 inches tall? Yes, he could. And so we keep going like this, 68.02. You can probably see what's going to be happening. You'd fill in with this whole line with dots. In other words, this whole thing would be covered with dots. Well, that's called continuous type of numerical variable. Notice there are no gaps here. Everything is filled in. We also have levels of measurement. We have them here listed from the lowest to the highest level. And what happens is that as you go down from low to high, there's more you can do with the data. You can do more math as you go down. You cannot do much with nominal data, but with ratio data you can do lots of things. So we want to go through these 4 levels of data because you want to recognize what they are when you're gathering data, because that'll dictate what kind of massaging you can do to the data. The lowest level is the nominal level, and these are just the word nom, or the stem nom comes from name, like nominate, name somebody. These are just names or labels or categories. So a person could be married, divorced, single. So if we ask someone their status, they could give one of these words. Or they could say to the question, are you a independent? They could say yes or no. So a yes-no response. This is nominal level data. Now you cannot do much with this. You can't calculate averages and so on. You could make graphs, maybe a bar graph, if you had yes, no. You could indicate the number of people that said yes compared to the number of people that said no, and I guess that would help clarify the situation. But other than that, there's not much you can do with nominal level data. Now with the ordinal level, they call it ordinal because you can put in order these data. So a person could be ranking their teachers. They could say the teacher is fair, the teacher is excellent, good, and so on, poor. These are names, so these include nominal. All of the higher levels include the lower levels, but they have something added. They can be put in order. In other words, if you start at the worst, poor, then next would be fair, and then would be good, and then would be excellent. But there's not much else you can do with this data. Again, you could make bar graphs. I guess you could indicate a mode. A mode would be the response that occurred most frequently, so that could be possible. But the difference between these two and the difference between these two are not the same thing. So differences don't make sense. The difference between fair and poor and the difference between excellent and good, it's hard to understand whether those are the same or not. So differences don't make sense. You can't do much with ordinal level. Now, interval level data, on the other hand, here differences are meaningful. So, for example, if a person said to you, "What was the year of your birth?" Someone was born in 1990 and another person was born in 1985. Well, these are nominal in the sense that it's the name of a year. They're also ordinal because they could be put in orders, but they are finally interval level because differences now are meaningful. If I subtracted, difference is the answer you get when you subtract 1990 minus 1985 is 5 years. Does that mean anything? Is that meaningful? Yes, there's a 5-year difference between those 2 years. So if a person was born in 1985, they're going to be 5 years older than a person born in 1990. So this is meaningful. So differences are meaningful. So you can calculate certain kinds of averages like means. Now, temperatures so today's temperature is 60 degrees Fahrenheit, and yesterday was 70 degrees Fahrenheit, and so on. Can we put these in order? Yes. So these are interval level data, and are differences meaningful? Well, if we subtract these two, we get 10 degrees. Well, 70 degrees Fahrenheit day is 10 degrees hotter than a 60-degree day. Now, do these two examples have true zeros, true starting points? Well, if you go down temperatures, you go down to 0 degrees Fahrenheit. Is that the starting point for temperatures? No. You could go below 0, couldn't you? So we have no true zero here. And the same thing for years. If we go down the years, 1990, 1090, the year 10, the year 0. Is that the beginning of time? Is that the starting point for time? No. Don't you have before the Common Era, whatever you want to call it, BC? Don't you have 30 BC? And so on. So there is no natural zero for interval level data. And when that happens, then division is not meaningful. Division is not meaningful. So, for example, if we had a 90-degree day, very hot, and a 30-degree day, and you divide that, you get 3. Does that mean that a 90-degree day is 3 times as hot as a 30-degree day? I don't think so. So division is not going to be meaningful for interval level data. Finally, the highest level is going to be the ratio level. And with this kind of data, you can calculate all kinds of statistics. There's no limit on what you can do here. And what happens with ratio level is that ratios, which means divisions is meaningful, and you do have a true zero. So if I ask you for the cost of items, well, something costs $50, something costs $20, something costs $100. Well, these values. They could be put in order, ordinal, but more than that, differences are meaningful. If we subtract these, $30 means something. One item costs $30 more than the other. So that would be the interval level. And then finally, division is also meaningful. A $100 item divided by a $50 item is 2. Well, it makes sense to say that the $100 item is 2 times more than the $50 item. And division is meaningful because you have a true zero, because these items, $20, $19, and so on, they go all the way down to a starting point of $0. So we do have a true zero for ratio level data. That's the end of Unit 1B. See Unit 1C for an introduction to statistics sampling.